Hey everyone, welcome to 5.9 Inverse Trig Functions and Integration. Alright, so we're going to be basically the same thing that we did in the last section, but now we're taking the integrals rather than the derivatives. Okay, so if you see below me down here, I've just got three of them, arcsine, arctangent, and arcsecant. So you can see you've got a squared minus u squared is u over a, and notice how it says du right over here. So u is kind of like our x. U is our variable, a is just going to be a constant. Alright, so what we're going to do here is let's look at this first example. Let's say, okay, I've got square root 4 minus x squared. So I look at these three things that I have below me and I say, which one of these things down here is really going to work out? I see the first one, square root a squared minus u squared. Okay, that seems pretty much good. The second one is a squared plus, and the last one has a u and a square root outside. So it looks like this first one's going to be the best one that we're going to have to use. So the first thing I'm going to say is I'm just going to say a equals 2, because 2 squared is going to be 4, and I'm going to say that x equals x. Alright, I might be able just to write something like that, because really that's what we're doing is I just want to be able to figure out what are these numbers that go in for a and u. So maybe I could say u equals x. Maybe that's a better way of writing. U just equals x. Okay, good. So then I can just rewrite this thing maybe as like the integral of dx over the square root of 2 squared minus x squared. Alright, so then if I do that, I say, okay, I can just say this is the same as arcsine of u over a. Our u is just going to be x over a is 2 plus c. So it should be, oh, I didn't really write this right. Arcsine x over 2 plus c. And x plus 2 should be in parentheses, I guess, but not necessary. Okay, so now let's do this one. So I've got dx over 2 plus 9x squared. Alright, so I'm going to say, which one does that look like? Well, I'm thinking it looks like this one. Yes? Yes, it does. So I'm going to say that a is going to equal the square root of 2, right? Because this thing is going to be a squared. Okay, there we go. Alright, so I'm going to say this 2 equals a squared. Alright, so that means square root of 2 squared is that. And I'm going to say that u is going to be 3x. Because 3x squared would give you the 9x squared. So then I'm going to say that du, I have to take this, and it's going to be 3dx. I don't have the 3 in here, so I should make sure that I include that 1/3 in here, right? So don't forget that 1/3. So I can say this is going to be the same as 1/3 integral of du. We can keep it as dx and just say square root of 2 squared plus 3x squared. Alright, so now we can use this formula right here. So it's going to be, we have the 1/3, let's just write it down here, 1/3 times it's 1 over a, which is a is square root of 2, so it's 1 over square root of 2. And then we have arctan of u, which is our 3x, over a, which is square root of 2. And that is going to be plus c. Keeping that, just cleaning up just a little bit more, we can end up with, let's see if I can get this right here. Come on, computer. Let's go. There you go. So it's square root of 2 over 6 arctan and 3 square root of 2 over 2x plus c if we really want to be able to figure out all that stuff with rationalizing the denominator. Okay, and here's the last one. If you look at this one, you say, okay, I've got dx all over this whole thing, and it looks like, oh, sure enough, it looks like the last one. So I can try and figure out what does this last one pretty much look like. Well, let's just say u equals 2x, right? So if I say du, that's going to equal 2, right? Okay, I've got that. And what is a going to equal? A equals 3. Right, so now I've pretty much got everything set up for the most part. Here's the only problem. I should have a 2x here, and then this should also be a 2x, right? Because the u that's down here should be the same u that's in between both of these, right? So we kind of have to say, well, if we put a 2 in here, I've got to put a 2 up there. And now we've got that u to be just right. So now I can say this is the same as 2 integral of dx over 2x square root of 2x squared minus 3 squared. I'm just putting all those squares in there just so that way you can see it all. Alright, so now I can say, alright, I know what a is, so I'm going to say 1 over a, which is 3. Then we have arcsecant of the absolute value of u, which I have as 2x, all over a, which is 3, plus c. All right, so there would be my answer there for this one. Okay, good. Now let's go through and let's look at this next example over. Oh, sorry, you can't really see that. I didn't really do a good job of checking to make sure you can actually see it. So I moved it over here so that way you can see it. There we go. All right, so now I've got this one. I'm going to actually write it down here just because I kind of ran out of room for myself here. So let's just go ahead and put that in there. All right, so I have square root of e to the 2x minus 1. All right, so it looks as though I might have to do something with maybe this one, or I might have to switch some stuff around. So let's actually see what we have to do. So the first thing we should do is let u, I can probably write it right here, u is going to equal e to the x. U is going to equal e to the x. No? Alright, so here we are back at the integrals after some technical difficulties of this one. So let's first do u is going to equal e to the x. Okay, that makes sense because e to the 2x is the same as e to the x all squared. Right? So we can say that, and then we know that du is going to equal e to the x dx. Right? So that seems all fine and good. So then what we can say is that if I want to figure out what this dx is, why don't we just divide it by e to the x, divide by e to the x. So then you can say du is going to equal, or du over e to the x equals dx, and that's really just the derivative of u, so we can say this is du over u prime equals dx. Okay, so now we can rewrite, after all that work, we can rewrite this as the integral of du over u times the square root of u squared minus 1, right? So far so good. Which one uses that thing that looks like that? Oh, that's right, this one does. So we can use arc secant. That one's a little bit off. Let's just move it over here so we can see that plus c. All right, so really what we can do is we can just rewrite this as 1 over a. I know u is just going to be u, and a is going to equal 1. 1 squared is 1. So we can say this is the same as 1 over 1, kind of pointless to say, but arc secant of absolute value of u, and u is just e to the x. E to the x is always going to be positive, so we don't need the absolute value, all over 1 plus c. So that looks kind of ridiculous. So we'll say arc secant of e to the x plus c. And that should be our solution. There you go. So that's it for this video. Tune in to the next one to see how to do other examples.